All right, so again, this is the procedure that is suggested by the book. Sometimes I kind of disagree with the book. So first, choose the leftmost non-zero column and use the appropriate row operation to get a 1 at the top left, basically. Then use multiples of the row containing the 1 in the top left and get zeros to everything below that. And then repeat the step 1 with a submatrix, followed mentally by deleting the row used in step 2 and all rows above this. So they're basically saying, get a 1 and make that a 1 and then get those zeros. And then go over here, make that a 1, get that to be a 0. Then go down the next row, make that a 1, and then there's no zeros below that. And then after that, start going up, make those zeros. Then after that, make that a 0. And there's kind of how they're talking about it. Now, if we obtain a row with all zeros to the left of the vertical line and a non-zero to the right, we can conclude there's going to be no solution. So if you get to the point where we have, like in our initial thing, we had a 1, 0, 0, 0, 1, 0, 0, 0, 0, and then we had a x, y, and a z. So we had 0 is equal to 0. 0 equals z, that's no solution. So we can stop at that point. We don't have to go any further. So that's kind of a nice thing. You don't have to keep going trying to get zeros up there. All right, so that's kind of the procedure. And again, they're sometimes saying instead of doing going down and down and down, they say go up at this point, but I say go down, 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 and then at this point go up, and then this point go up. It saves a step. All right, so looking at this one. Solved by Gauss-Jordan elimination. So again, write the augmented matrix. And now what we need to do is we need to simplify. So I'm going to take half of the first row as my first step, and that's going to be my new first row. Take negative 2 times the first row, add it to the second row, that's going to be my new second row. And add the first row to the third row, and that's going to be my new third row. And let's see. So they took half of the first row, got this. But then they're saying, okay, well, let's take a negative 4 times that, add it to that, and then 2 times that and add it to that. So they're kind of doing, one step here, but then 2 steps beyond. I could do all 3 in the first one if I wanted to. I could have said, instead, I want to do that. And then I also want to take minus 2 row 1 plus row 2 goes to row 2, and row 1 plus row 2, or 3 rather, goes to row 3. And I could go straight from there all the way down to here. Okay, so it just saves a step of writing it all out, but it doesn't matter. You could do one here, make a new matrix. Do one here, make a new matrix. Do another one, make another matrix. And so some people like to do one step at a time so they don't mess up. Some people want to do as many as possible. So it's all up to you on how you want to do that. All right, so now when we get to this point, what we need to do is we need to make this a 1. So to do that, they say take, times zero point 0.2, or I could just say divide by 5. That's another way to think about that one. And so then you're going to get 2 here and a 1 here. And then after that, we need to make that a 0. So we're going to take 2 times this plus this, and we get 0 here and a 5 here. And look at that. We have no solution because all zeros here and then a 5. So that makes a thing where we just have to stop and we don't have to go any further. So we're done. And see, that also is a point where I wouldn't, where's my writing utensil? I wouldn't do this step at all. I would wait until I got all the ones all the way down and zeros below that before I start moving up. Because at that point, I wouldn't have had to do the extra operation. I would have just I would have had this, and I would have had this, and then I would have got down to this line and said, oh, I don't have to do that anymore because it's no solution. Whereas they did that extra operation. So trying to think smarter is kind of an easier way to do it so you don't have to work harder. All right, so now with the calculator, we're going to do basically, same thing. We're just plugging it into our calculator. And so I kind of showed you this on row reduced echelon form, except I did it like on a smaller one. But we type all that into a matrix. And so the matrix is going to be what? 3 by 4. And so we have 3 by 4. And, we can't really draw that line in our matrix on that calculator, but that's kind of what we'd have there. And then we're going to say, okay, we do that row reduced echelon form for A, and it gives us this. Okay. Now it gives us that 0 up here, and that's why they wanted to put a 0 here so it matched what you get when you do the row reduced echelon form here. But you don't have to, because once you get to the point here where you get all zeros and then equals 1, then we know that that's a false statement, and so it's no solution. So basically, what it's saying is your graphing calculator doesn't stop when a contradiction first occurs, but basically continues and completes the reduced form. Hence, they matched what we have they had showed there before. All right, so the last row, though, still produces that contradiction and no solution. All right, let's stop there and we'll come back for some more.